name is Prasad Nagaraj, currently Vice President Engineering at ScaleGrid. Last session for the day I believe, so I will try to keep it simple and short. So at ScaleGrid we are into database as a service solutions. We have pretty strong solutions for Mongo and Redis that are available, and pretty soon we are going to launch MySQL and PostgreSQL hosting solutions as well. So the topic for today is MySQL high availability using semi-synchronous replication. We are going to make use of some of the Linux open source HA framework, specifically Karosync and Pacemaker. So the agenda for today, let me start with a brief introduction on what exactly is high availability. Then we will kind of deep dive into MySQL high availability in little bit more details. We'll also look at some of the common scenarios, specifically failure scenarios, and how this framework helps us to detect and recover from such scenarios. And we will wind it up with a summary and solution information. So what exactly is high availability, right? So it is basically the percentage of time your services are up and running in a given period of time. It is usually represented as a series of nines, as you can see in this table. And what exactly high availability means for each of you really depends on your own business requirements. For example, if you are expecting a high availability of say 6 nines, that means you cannot afford any downtime which is more than few seconds. That is spread across entire year actually. So for the high availability framework to work, there are some fundamental components that needs to be in place. Let's look at those components. The first one is there has to be redundancy in your infrastructure and data. What we mean by this is there has to be a redundancy for your servers or hardware or software, and also there needs to be a redundant copy of the data, right? So that in case of a failover we can make use of all this. There has to be a mechanism for failure detection, which is basically if there is a problem or fault with your primary server, it needs to be detected immediately, and if possible corrected also. Then there is a failover mechanism, which is nothing but identifying among all the standby infrastructure you have, which is the most capable system that can take over and start serving your data after the failover. And then finally there is also application and user redirection mechanism. So after the failover, all your user and application data or traffic needs to be redirected to the right servers so that your services can continue seamlessly. So specifically with respect to MySQL high availability framework, so how these components are implemented, right? So the redundancy in infrastructure and data. We will have a 3-node master slave setup, which is set up using MySQL semi-synchronous replication, of course. And I'm going to talk a little bit more on semi-synchronous replication a little bit later. The failure detection mechanism and failover mechanism is actually provided by our Karosync and Pacemaker infrastructure. We are going to talk about it also. And then finally application and user redirection. So we have a small component called DNS rerouting component, which is basically going to map the FQDN to the right IP addresses so that traffic is redirected to the right place. So let us start looking at the things in little more detail. So this is how the overall architecture or the stack looks like. So you have your application talking to the master MySQL server using FQDN. So with respect to MySQL itself, you can see that there are 3 instances of MySQL running here. Of course, in master-slave configuration, and they are configured in semi-synchronous. They are configured to replicate in semi-synchronous mode. And then you have at the bottom, you have pacemaker and CaroSync running across 3 different nodes that we have set up here. You can also see a small component called RA, which is in green, which is nothing but a resource agent, and it helps us, or it helps the pacemaker to interact with the resources. And resources here, what I mean by resources is actually our MySQL service. And the beauty of this architecture is it is pretty generic. CaroSync and pacemaker can provide high availability to any of the resources. It could be your web service, or it could be any other database like Postgres. As long as we have a custom resource agent running that can understand the resource, this framework will work. So we can look into details of each component here, starting with CaroSync. So CaroSync, the basic functionality of CaroSync is to ensure the nodes in the cluster are able to communicate with each other in a reliable fashion. So while doing this, it is able to form a ring between the nodes, resulting in a cluster, and it is also able to identify which nodes are joining this ring, which nodes are leaving this ring, which node is up, which node is down, things like that, which is going to be very helpful for failure detection. So the next component is, of course, pacemaker. It is also known as cluster resource manager. The functionality of pacemaker is basically on one side, it works with, it interfaces with CaroSync so that it understands the states of the nodes in the cluster and can also deal with node failures and so on. And on the other side, it interfaces with the resource so that it is able to handle any resource state changes like resource failures and things like that. And most importantly, it can configure and control the resource through a set of primitive operations. I have listed some here. For example, it is able to start the resource, stop the resource, monitor resource, and so on. So the third component what we have here is actually called as resource agent, and as I mentioned before, this acts as an interface for the resource, between the resource and the pacemaker. So this is the agent which actually implements various operations like start, stop, and all these that the pacemaker is going to call or make use of to talk to the resource or manage the resource. So for this particular solution, we are making use of a resource agent for MySQL developed by Percona. There is a company called Percona, they are MySQL experts. So of course it is enhanced by ScaleGrid. So this is the GitHub link, and this particular is called Percona Replication Manager. Then talking about the semi-synchronous replication itself. So the way semi-synchronous replication works is, when the master is getting the data, it can commit the transaction only after receiving acknowledgements from the slave. So there is a continuous replication going on, and master keeps sending data to the slave, and also it receives an acknowledgement from the slave that it has received so much data. So a particular transaction can be committed on the master only after it gets an acknowledgement from the slave. That means the data has already reached the slave. So the benefit of this is, so in the event of master failure, right, so we can be sure that all the transactions that are there in the master are available in at least one of the slaves. It has been replicated to at least one of the slave. And subsequently, the crash of the master and the failover to the slave is going to be lossless, which is very important for us. Since the data is already present on the slave, failover to that slave, we will not be losing any data as it is up to date. Yeah, I mean, it's a very interesting topic, and you can refer to this website for more details on how semi-synchronous replication works. The number of slave acknowledgements that is needed by the master before it commits the transaction. So in our case, we are setting it to 1 because we have a 3-node cluster and we have 2 slaves. So it is sufficient for us to get the acknowledgement from one of the slaves that it has received the data. So this is set to 1. So another important configuration is related to the timeout. So basically a timeout can be configured, which is basically how much time the master will wait to get the acknowledgement from the slave. So it is very interesting. Actually, what happens in case the master is not able to get the acknowledgement from the slave before this timeout, the behavior is that MySQL is going to fall back to asynchronous replication. From semi-synchronous, it is going to fall back to asynchronous replication. And if it does so, it's actually not good because in asynchronous replication, there is no guarantee that slave has got all the data that the master has committed. So subsequently, if something happens to the master and there is a failover, we could potentially lose data. So it is very important to ensure that the master keeps working in a semi-sync mode all the time. So we are kind of setting this particular configuration to a relatively higher timeout so that it doesn't fall back to asynchronous replication. I mean, in case of a slight delay from the slave in sending the acknowledgement, it doesn't fall back. Okay. So I'm going to talk about some of the practical, common, or day-to-day scenarios, specifically failure scenarios, what could happen and how this particular framework can recover from that. So most common scenario, let's assume the master MySQL server goes down or crashes. So what is going to happen with respect to failure detection is the pacemaker running on that node is going to immediately detect that MySQL is no longer running or it is down through the monitor operation. And once it detects that MySQL is down, it is going to demote that MySQL. Demoting means it's saying that this particular node cannot function as a master or primary anymore. So with respect to data redundancy, we have talked about this. So since we are using semi-sync protocol here, so we can be sure that all the data or the transactions committed on the master is already present on the slave or replicated to the slave. So third part is the failover. So basically pacemaker, once it sees that the cluster doesn't have a master or a primary, it is going to initiate a process for failover. And during failover, what is going to happen is the slaves that are in the cluster are supposed to return what we call as scores to the pacemaker, promotion scores. And these scores are an indication. They are nothing but how close the slave is with respect to the master in terms of the transactions executed. So if the slave has already caught up with the master, it is going to return a positive score. If the slave is still behind, it is going to return a negative score to the pacemaker. So once pacemaker receives the scores from the slaves, it is going to identify the right slave, which is basically the slave that has returned a positive score, and it is going to promote that slave as the new master or the new primary. So promotion is nothing but making that particular MySQL instance. Generally slaves will be running in a read-only mode. So once it is promoted as master, even the writes are allowed on that node. And also the remaining node, right now we have only 2 nodes because the first node is down, or the first instance of MySQL is down. So the remaining node will be reconfigured to start replicating from the new master. So finally there is this application redirection. Once promoted, the resource agent triggers a DNS rerouting module, which basically updates the FQDN or the DNS name that we are using. It is going to map it with the IP address of the new node that got promoted. So this way all the application writes will be redirected to the new master now. So let's look at another scenario, which is basically slave MySQL going down. Again, the beauty of this architecture is it is not really limited to monitoring the master or primary of the cluster and enabling failover. It monitors the entire state of the cluster. So basically it wants to make sure that all the nodes in the cluster are healthy and running fine. So in this particular case, if the slave MySQL server goes down, again the pacemaker on that node detects this failure, and in this case, of course, there is a healthy master that is running and no need to get into failover and things like that. At this point, it tries to recover the resource by doing a stop and start or restart of the MySQL. So if MySQL comes up fine, it will be added back to the cluster as a slave, and the business continues as usual. I mean the replication continues. So in case MySQL is not able to come up, there are options to kind of set up alerts or notifications, so that, I mean, in case any manual intervention is needed, that can be handled. Okay. This is again another scenario, but a very interesting scenario. This is the scenario of network partition. So basically what is going to happen if network connectivity breaks down between master and slave nodes? So this is also known as a split brain scenario, if you have heard of it before. So what is going to happen here, since there is no network connectivity between master and slaves, the resultant cluster now is partitioned into 2 groups. There is one node running on one partition, and there are 2 slaves running on the other partition. And what is dangerous here? Split brain is a very dangerous scenario because the pacemaker infrastructure that is running on the partition where the 2 slaves are running is going to detect that that particular partition doesn't have any masters at all, because only 2 slaves are running there, and it is going to promote one of the slaves as the new master. So if that happens, we will be ending up with 2 masters running on that cluster. So one is individually running by itself, whereas in the second partition, it just promoted one more node as the master. So you have 2 MySQL masters running, which is very dangerous and kind of leads to all sorts of complex problems. So we need to really avoid that, and the way to avoid it is basically through a pacemaker configuration called no quorum policy. What we mean by quorum here is, in case of a cluster, it is about the majority of the nodes. A cluster is said to have a majority, or is said to have a quorum when, in case of a 3-node cluster, if at least 2 nodes are working fine as part of the cluster is said to have a quorum. So in our case, we have 2 partitions. There is only one node, master, running on one partition of the cluster, so it doesn't have a quorum. So there is another partition where 2 nodes are running, and it does have a quorum. So because of this particular setting, no quorum policy equal to stop, the pacemaker is going to shut down the MySQL service running on the master node. And anyway, pacemaker infrastructure is also going to promote one of the nodes as the master. So finally, we are in a state where the cluster, one node is down and there are two nodes up with a master serving data or taking writes. Okay, I think that was pretty quick. So at ScaleGrid, so we have implemented MySQL as a service, and specifically MySQL high availability is implemented based on the design or concepts that I explained just now. We are making use of MySQL 5.7.21. It is hosted on CentOS VMs, and it is running CorosSync 1.4.8 and Pacemaker 1.1.14 stack. We have also done quite a bit of enhancements to the resource agent or the Percona replication manager. Of course, it is posted on our GitHub account. So some of these changes are to enable semi-sync replication in the resource agent. And also there is more robust timeout and failure management. So what happens is basically Pacemaker is very sensitive about the failures and the timeouts and all that. And in the original PRM or the resource agent, so if MySQL, for example, doesn't respond temporarily for health checks, the pacemaker is going to consider that the node, that particular MySQL instance is down and initiate failover and all those things. But we have built a more robust timeout and failure management, so that in case of temporary non-responsiveness, there are retries and things like that. So some security enhancements as well. In the original script, it needed the MySQL account to have super permissions, but we have done away with that as well. So yeah, please do visit us at our website to know more about this particular hosting solution. And that's pretty much what I had for this presentation, and I'm open to take questions.
So you mean to say master once is detected failed, the slave becomes a master.
Slave becomes a master.
So master once restored, it becomes automatically a slave?
Automatically it joins the cluster as a slave, correct.
Okay.
You covered only master slave only, right? What about master replication?
Currently we are not supporting master replication. It is just in master slave mode.
This DNS rerouting, what you are mentioning, is it same as in the MySQL 8, they were talking something like MySQL gateway?
It is similar but not exactly the same. So DNS rerouting, what happens is we have a FQDN, which is basically the address of the primary of that MySQL setup. But internally what can happen is at various times, various nodes can take the role of the master. So each time this happens, that FQDN needs to be updated in the routing tables to point to the right master IP address.
But that may not be with the actual latest status of the master, correct? No. Then when the master, then there is some kind of inconsistency between that actually. Ideally, the other master is having the latest state, correct? No.
So what is happening here is basically, since we are using the MySQL semi-synchronous replication, right? So we are assured that all the data that master has already reached at least one of the slaves. Otherwise, the master is not going to commit rest of the transactions. So in case there is a network outage, and if you are continuing to write to original master, so those transactions are not going to be committed to InnoDB engine because the replication is broken.
A slave which has a highest score, that may not be in the real sync of the master, correct? You know?
So basically we are not taking the slave with the highest score. Probably I think that's what my slide read. Probably that is a little incorrect. So basically we are going to check and promote the slave which is up to date with the master. Sure, sure, yeah, I'm going to correct that, thank you. Correct, sir, correct.
So what is the minimum time we need to set for avoid asynchronous replication from semi-synchronous to asynchronous? We need to set some timeout for waiting the commit state from slave, right?
So basically, I think if I remember this right, I think the default timeout is 10 seconds. That is the default timeout in MySQL. But we have increased it to 5 minutes.
Is another question, the DNS proxy, do we need to install it in application side for redirecting? Say if master IP we can hard coded into the application side, if it is switch failover, then application is keep on hitting into the old master IP only. So how can we redirecting into the new promoted masters? How can we intimate applications to the new promoted masters?
Right. So basically, the DNS proxy is our internal component here. So the applications are going to talk to the database server through a DNS name, not the IP address. So for example, master.scalegrid.com. So that is the DNS name that the applications are going to use. And that master.scalegrid.com is going to map the IP address of the current running master. So in case of a failover, so it is going to be remapped to the IP address of the new master. So that, I mean, there is no change per se on the application side. They will continue to use the same DNS name, but traffic gets rerouted automatically. Yes. Application need not be aware of this setup. That's what I mentioned. Correct. All the connections are internally managed. So application is at a high level and it is going to talk to only master@scalegrid.com, which is that master node. Correct. 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 That is correct. I mean, if there is an outage in the connection and all that, it will try to re-establish the connection, and once it does that, all the traffic goes to the correct master.
One question here with respect to split brain condition. So when the master, this is semi-synchronous setup we are talking about. So semi-synchronous waits for certain duration. If the commit didn't come, it will proceed with the transaction rather than it stops there. So in the case of split brains, rather than stopping the master or killing the master node there, do you do any IO fencing that it will restrict any IOs to perform on the database rather than just killing it, because it can be a glitch rather than a complete changing the master, because that's an expensive operation.
Correct.
So do you do any IO fencing there?
Correct. We are currently not doing any IO fencing right now, but we are looking into it. But currently we want to prevent, I mean,
So
two masters
right
up and running at the same time. So we are making use of this configuration.
Yeah, I'll ask it again. So I had a question on indexes. Will you support slave-only indexes in the setup, where the indexes, read-only indexes are only for the slave? So will that be supported?
I really need to check back on that, but right now the assumption is all the MySQL instances are uniform, right?
The reason
except that the slaves are read-only. Other than that, all the instances have the same kind of configuration.
I'm sure you would have understood why I asked that.
Got it. Yes, that is correct. Yeah.
And
I'll need to check back on that. Yeah.
And I also had another question on this thing, the replication lag, because you said after a certain amount of slave delay, it's auto-promoted to master, right? Like you have a timeout there, and if in that timeout there is no this thing, then it is auto-promoted to master, right?
No, it will not be auto-promoted. Only after the slave catches up with the master, it will be promoted.
Okay, so then there cannot be a transaction break off in any way.
That is correct, yes.
All right, that answers it. Thanks.
You are depending on the pacemaker to know the monitoring status of the MySQL basically. But if the pacemaker itself is not working actually, then your whole setup will this thing. You know.
Yeah, so this is the distributed setup, right? So the pacemaker and CoroSync are working across all the nodes. Sorry? Yeah. So if there is a pacemaker down on one of the nodes, the pacemaker infrastructure is still available on the rest 2 nodes. So they are going to detect that pacemaker is not functioning in one of the other nodes and they are going to take corrective actions. Right now, this is implemented in the cloud, but I don't see any reason why it cannot work on on-premise.
So when this failover happens to master slave in case of any kind of failure, does this application transparent? Or application will come to know there is a failure?
Application will come to know there is a failure because I think for temporarily the connections will not be available during the failover time, but subsequently the connections.
Connection will not fail over to the new master or the new wherever it's connected to.
I think there is going to be a temporarily outage in the connections which will have to be re-established.
Okay.
Correct. Correct.
Since the proxy has made the change, so
Correct.
it will detect that it has to go to a different.
Correct. I mean the MySQL that the application talks to will not change. It is the same communication channel, but there will be a temporary outage during the failover time.
The temporary outage, you have seen. I mean, you have seen any measures or metrics, anything related to that? How much time for some application?
So basically, during a failover, we have seen about 60 to 120 seconds of downtime for the applications.
Small apps or bigger apps?
So right now we have been testing only with our test applications in our labs. So it is basically the moderate load of about 200 IOPS per second. Yeah.
Okay. Across the master to the slave, it's 200 IOPS per second, more or less.
Just to the master. So it has a combination load, writes, updates, reads, right, on the master. And slaves have their own reads happening.
Okay, good. Thanks.